TCP/IP organizes IP addresses into subnets. Then IP routing uses those subnets for more efficient routing. In this video, you'll learn about the 4 key facts you can calculate about any subnet. All my CCNA content videos match the scope of one section of the official CCNA Cert guides. In this case, Volume 1, Part 4, Chapter 14 from the second edition that came out in 2024. That chapter has 3 major sections that you see on the left with those titles. And the first section is defining a subnet, and that's what we'll do here in this video. So within the video, we'll have 2 sections. First, we'll talk about the structure of IP addresses, which then helps us understand these 4 facts that you can calculate about any subnet. Stick to the end of the video and I'll deliver on 3 important promises. As always, for you book readers, I'll tell you what in that matching section you should for sure read and what you may want to read. Then for everyone, I'll tee up at least 1 review exercise. And then finally, something extra. In this case, we'll talk about something called classless addressing that we haven't talked about before. Let's start by revisiting our analogy about postal addresses. Here are a couple of houses on our favorite street, Cherry Street, and we see the addresses over here, and we see that much of their addresses are identical. Unsurprisingly, right? They're next door neighbors. So everything except the street number or street address is the same in their addresses. And we'd expect that in postal addresses, right? So it's identical for the town and the state here in the US and the postal code. It's identical for the street, but differs in that street address. Now, continuing that on a bit, if you have 3 different streets with some houses in there and you look at the addresses in there, of course, the town and the state and the postal code will be the same, but both the street address and the street will be different comparing one street's addresses to the next. So all the addresses in the same postal code will be the same, but comparing street to street to street, the street name will differ, of course. Now, we see similarities like that in how IPv4 addresses are grouped into subnets. So let's talk about the structure of the address. Now, it has structure in terms of how you and I think about it. So it's not like there's something that goes along in the packet that says this is the structure. It is our thoughts. So if we look at any 32-bit address as a rectangle, we can think of it as a 3-part structure with some bits we call network bits on the far left, subnet bits in the middle, and host bits on the right. And these dividing lines between here varies based on the mask that's used to perform subnetting. And you're going to learn the rules of that and how to apply that for your CCNA studies. But the basic general idea is just that. So what does that work like? Well, instead of the thing that's in common in US postal addresses being on the right, with IP addresses, it's on the left. So all the addresses in the same IP network have the same value in the network part. Then there's a subnet part. It's kind of like the street name in the postal address analogy. For addresses in the same subnet, the second bullet's important. If they're in the same subnet, it's the same number in the subnet part. But if they're in different subnets, different values in the subnet part. Same street, same subnet, different subnet. Then addresses, the host part, it's like that street address or street number. It's unique within the subnet. So next door neighbors would have something different, if you will. So 2 PCs in the same subnet will have different values at the far right part of their IP address. The dividing line just differs in different cases based on the mask value. So let me talk you through this example. We've got address 10.1.1.3 with this familiar and easy case with the /24 mask. So what do we know? Well, even from earlier videos, we know that addresses that begin with 10 are part of a Class A network, and that in Class A networks, it's 1 octet, the leftmost octet, that makes up the network part of the address structure. So we've got 1 octet of network part. The other thing we know is this /24 means the mask has 24 binary 1s, which leaves 8 binary 0s. And get this, The binary zeros in the mask tell us where the host bits are, where the host part of the address is. So the last 8 bits, in other words, the last octet on the far right, is the host part. So the .3 lands in the host part. Everything in between is the subnet part. So what does that tell us? Hey, this address is part of Class A Network 10. There's 1 network octet. We've got 2 subnet octets in the middle. All addresses in that subnet begin with 10.1.1. And then the last octet is the host field. And those values are unique within the subnet, just like street addresses are on a street. Let's talk about addresses first. The idea of an IP address is defined in the very RFC that defines the Internet Protocol. It's defined as a binary number that's 32 bits long. It's defined as being represented as a dotted decimal number for convenience. But it's defined to be used as an identifier for an interface. For instance, a router might have 10 interfaces connected to different parts of the network, and each interface would have an IP address. So IP addresses don't identify a node, the whole computer. It identifies interfaces connected to the network. Packets that flow through the network have a source and destination address, so they're used to identify the senders and receivers of packets. And because of that, routers have to do table lookups based on the destination address of packets and compare those to their IP routing tables. So that's pretty important as far as how IP routing works. And IP routing relies on correct organization and grouping of IP addresses into subnets. Now, more important to our next few minutes is this last one, a value that when combined with a mask identifies a subnet. So if we want to understand what any one subnet is all about and those 4 key facts about it, take any address in the subnet, the mask used in the subnet, we can calculate the facts about that subnet. And we'll do that here in the next few minutes. Now, just to make sure you've seen one, here's a sample IP address. Here's the binary equivalent. I don't care if you know how to do that conversion or can do the binary math, but those are samples. Now let's talk subnetting. Here are some ideas related to subnetting, food for thought. So I'm just going to go through these and talk about it. Topologically speaking, we've talked about this before, but all the devices in the same VLAN, you would typically then give them IP addresses in the same subnet, or the devices on the same WAN link. 2 routers on an Ethernet WAN link, their IP addresses on opposite ends of the link would be in the same subnet. Conceptually speaking, just thinking about some of the math, it's a predictable set of consecutive addresses or numbers. So kind of like street addresses are one after the other to make it easy for the delivery of mail, subnets use addresses that are near each other, mathematically speaking, to make it easier for the delivery of packets. Subnets have a size. How many addresses are there in the set? Well, that's important. It's a power of 2 in raw size. And the location in the topology is important. Get this. Addresses in the same subnet should not be separated from each other by something that's doing routing. So, hey, we're in the same subnet. We're not separated from each other by a router. That's another subnet over there. They're separated from us by at least 1 router, that kind of thing. Now, mathematically, you can define a subnet with its identifier, subnet ID, plus the mask. If you don't have both, you haven't fully identified and defined a subnet. You need both, subnet ID and mask. Now, within a subnet, there are a bunch of numbers. Most of those numbers are addresses that can be used, but there are 2 reserved numbers in each subnet that can't be used, the subnet ID and something called the subnet broadcast address. Final fact to throw out, in the same subnet, this set of consecutive numbers, in all the addresses, the network, remember our 3-part structure, the network and subnet parts are identical. Right? So back to the postal analogy. Next door neighbors, most of their addresses are identical. Addresses in the same subnet, most of their address is identical. In particular, the network and subnet parts. So just for some perspective, imagine we had Class A Network 10 What are some of the subnet IDs you might come across? Well, here are a few if you're using a /24 mask. That's the simplest case. And these are numbers that would be subnet IDs. Here's some more, and here's some more. And it turns out you create a lot of subnets with that mask in a Class A network. But here are a few of them, so you get a sense for them. You might notice that they all end in 0. That's sometimes true and often true, but not always true, all right? So don't make too many assumptions based on these particular samples. We'll show you how to calculate them here in the coming videos. Now, some facts about the subnets. These are the 4 facts I've been alluding to that I want you to be able to calculate. So first off, the subnet ID, of course, we want you to be able to calculate a subnet ID. So it represents the subnet. It's the numerically lowest value in the subnet, and we can't use it. It can't be used by a host. You can't assign it to a host to use. On the other end, numerically, the highest number in the subnet is called the subnet broadcast address, and we can calculate that. It also cannot be used by a host as its unicast address. So once you calculate the low and high number, everything in between is usable, so we can calculate the first or lowest address that's usable and the last or highest address that's usable. How do we do that? Well, if we know the lowest number, we add 1 in the 4th octet to get the lowest usable. And if we know the highest number here, the subnet broadcast address, we subtract 1 in the 4th octet to get the highest usable address. All right, so that's how it goes. Now, I mentioned this idea of a subnet broadcast address. It doesn't get much use today, so it's a bit of an old term, but just so you see what it's about. The subnet broadcast address can be used like this. PC1 can send 1 packet. The 1 packet is routed, and if it's sent over here to the subnet broadcast address in this subnet, when it gets over to the right, it will be sent to all the hosts in the subnet. So a broadcast to hosts just in that subnet. So PC1 sends a packet to the right-hand subnet's subnet broadcast address. Router R1 just forwards it to router R2. When router R2 gets it, when it sends the packet into the LAN, it puts it in an Ethernet frame that's an Ethernet broadcast frame. So all hosts receive it. Everybody gets a copy of this subnet broadcast packet. When they receive it, they'll think like this: hey, the destination is the subnet broadcast. Let me process it and maybe reply. For instance, you can do a ping to a subnet broadcast address and often get multiple devices to reply back to you. So let's go over those subnet facts one more time. The subnet ID is reserved, and the subnet broadcast address in each subnet, they're both reserved. Then to calculate the useful or usable addresses, we take the subnet ID and add 1 to the value in the 4th octet to find the first usable address, and then subtract 1 from the 4th octet of the subnet broadcast address to get the last usable address. All right, so if you can find the subnet ID and subnet broadcast address, the rest of this is pretty simple. Now, last bit of big concept is correct use of addresses in subnets. So as drawn here, these 4 PCs are supposed to be in the same VLAN with some LAN switch or switches out here that are hidden in this diagram. So if those PCs are in the same subnet, we want to give them addresses. And let's just say we use that subnet number and that mask. Then you should build the skills so you can calculate those 4 key values and know the range of addresses and know that those 4 addresses would be legal and valid. So once you can do that math, you'd be able to figure out this is the subnet ID, first address, last address, and subnet broadcast address to check to see if your planning was correct in this diagram. Now, one of those rules I mentioned offhandedly was, hey, all the devices that should be in the same subnet should not be separated from each other by a router. Well, PC 1, 2, 3, and 4 are not. But what if we did something like this? PC 1, 2, 3, and 4 are way across the network from each other, separated by these routers, but they have numbers that place them in this one subnet. That's illegal. That confuses routing. That would be like, in the postal system, somebody that has an address that ought to be your next door neighbor being across town somewhere. or in another state, right? That would be ridiculous for delivering mail. It'd be ridiculous for delivering packets as well. All right, last thing before we wrap up this video, there's a lot of terminology here. So I wanted to mention a few terms that I probably haven't mentioned all of these yet, but there's a subnet ID or subnet identifier, but you'll also hear synonyms like subnet number and subnet address. You'll also hear prefix, in particular when you're referring to this thing called classless addressing that we'll talk about in just a bit. You'll even hear people say, instead of subnet this, subnet that, network ID, network number, network address, when they actually mean subnet. Let me say that again. People will use the term network ID, etc., when referring actually to subnets. And it's okay. You're having an everyday conversation with other network engineers, go for it. If you know what they mean, great, you've communicated. Just be aware that people do that. Who knows? Maybe you might even see an exam question and you say, well, that number, it's clearly a subnet, but they called it a network ID. Okay. Calm down, be flexible. I understand. Go answer the question. All right. Subnet broadcast address, here's a synonym for it from the RFC, directed broadcast address. Subnet mask, there's some other terms for it. Simply net mask or prefix length or prefix that has to do with that prefix style mask. And there's even the different mask types. You'll hear terms for those like DDN mask, prefix mask, binary mask. So lots of terminology there. Probably useful to work on remembering those. You'll get forced to while you're reading for CCNA, but it's worth maybe studying up on a few of these. In fact, we'll use that as part of our review coming up. I made some promises. Let's talk about those. This content mirrors Volume 1, Chapter 14, Section 1 from the 2024 release, Edition 2 book. That Section 1 is called Defining a Subnet, and you can skip it. There's nothing there that we didn't cover pretty thoroughly here in this video. Feel free to open it and look at it, but you don't have to. Second promise, review activity. We're going to have a terminology mind map. I'll have a review video for you, but you don't have to use the video. Just do the mind map. So here's the deal. If you'll do it, that's way better than not. So that's your starting point. So you could do it right now, and that's still a good thing. But it's even better if you'll give it 24 to 48 hours. That's better for your brain. And then best if you'll schedule it so you don't neglect to do it if you put it off. All right? Your seed term is subnet ID. If you're like, what in the heck are you talking about, Wendell? In this playlist, there is indeed a video early on that tells you about these terminology mind maps and how to make the best use of them. Third promise was some extra just related to this video, and I talked about this idea of classless and classful addressing. So here's the deal. Remember how I described IP addresses as three parts with a network, subnet, and host part? That is one way to think about addresses, and it's really all about how we humans think about it in order to achieve something with subnetting. That's great. Now, because this process identifies a network part, and that network part, you have to think about class A, B, and C rules, class rules. That's called classful addressing, this way to think about addressing. Now, that's useful sometimes, but sometimes you don't need to distinguish between what's in the front up here because, get this, all addresses in the same subnet, in this subnet, have this same value in all of this, the original network plus subnet part. So if that's all you need to think about, you don't have to think about, oh, is this in a class A, B, or C network per the original rules and distinguish that. And when you're thinking like that, people will just refer to this whole left part as the subnet part, or they might even call it the prefix. It's the initial part that's the same in every address, the prefix. Then the host part's still the host part for the same rules. So it's a two-part address, get this, that doesn't have a network part because it doesn't have to think about class rules. The absence of class rules means it's classless addressing. So there's a couple more terms you'll bump into. Now, classless and classful are tricky terms. Get this, They're used as classful and classless addressing. They're used as classless and classful routing. They're used as classless and classful routing protocols, all of which are different things. Isn't that fun? But for here, we just talked about classful and classless addressing. Thank you for sticking with me till the end of the video. I appreciate it. You may be new here. Of course, I'd love for you to subscribe. Please do. But give me a like and a comment and even a share in social media. Help me get the word out. This is a pretty important video. I hope you found it useful. Thanks a bunch, and I'll talk to you soon.